I had some questions about number 4 on the partial fractions worksheet, so I want to take a look at that one right now. The original fraction was 20x plus 9. It was over the quantity, I think it was 25x squared plus 20x plus 4. It's a perfect square. I factored it as the quantity 5x plus 2 times the quantity 5x plus 2 because you've got to factor your denominator to be able to get started. Because you have repeated linear terms in the denominator, remember that you have to have every single possible power of a repeated term, okay? Now, this is linear. We just have an x variable there, which means you're just gonna have a constant in the numerator. So, let me see what I did in my notes here. I did a over 5x plus 2 squared, and then I did b over just 5x plus 2 to the first. Okay, now, originally I was thinking, oh, I'll just use the Heaviside method and I'll do a substitution here. This one's really interesting because we only have the 5x plus 2 term. Something kind of weird happens. If you remember, the idea normally is you say, hey, I'm going to figure out what makes this part equal to 0. And I'm going to cover that up in the part over here when I substitute that value in. Well, negative 2/5 is what makes that denominator 0. Okay? The problem is everything that's in that denominator would go to 0. And so you're going to get something undefined regardless of what you substitute into here because it's all the same thing. So unfortunately, the Heaviside method really isn't going to work very well here. And that's why I think understanding the basic process is always important. So you can always turn this back into kind of an Algebra 1, Algebra 2, just adding fractions problem. And I know it's not Algebra 1 or Algebra 2 problem, but basically it's really just adding fractions. So if I want a common denominator here, this would also need to be multiplied by 5x plus 2. And of course, you have to multiply the top and bottom by the same thing. And anyway, if you simplify, you've got 20x plus 9 over the quantity 5x plus 2 quantity squared. That's going to be equal to, now you're going to have the same denominator here and here. So you're really adding these two numerators. B is getting multiplied by 5x, B is getting multiplied by 2. So I've got the A, I've got 5bx, and I've got 2b, okay? Everything being added across the numerators. And we're just gonna have a common denominator here, so it's over 5x plus 2 quantity squared. So if you want to multiply both sides by 5x plus 2 quantity squared, and you want to knock out that denominator, that's great. It really doesn't matter though. The point is 20x plus 9 has to be equal to this, okay? That's really what I'm gonna be focusing on, all right? So if you come back and take a look at this, I only have one x term, okay? And it's got to equal 20x. So 20x has to be equal to 5 times b times x. This has to be 20, okay? It tells me that b is going to be equal to 4, okay? Look at your constant values, okay? The constant values need to add up to 9, okay? And we have two constant values. A doesn't have a variable, 2b doesn't have a variable. So a plus 2b has to add up to equal 9, all right? Great thing though, we already know what b is. b is 4, okay? So we've got 2 times 4, which is 8, plus a is equal to 9. That means a is going to be equal to 1, okay? I think at the end it asks you for the partial fraction decomposition, so do write it with the substitutions made. Our a value here is going to be 1, so it'll be 1 over the quantity 5x plus 2 quantity squared, or you can multiply that out and do 25x squared plus 20x plus 4 if you prefer, and b is equal to 4. And that is our final partial fraction decomposition.